Welcome to the OTech Talks podcast, where it's all about working on technologies. You will hear the latest tech information, and your host, Kashif Manzoor, brings together product overviews, how-tos, best practices, tips and tricks, and troubleshooting techniques.
OTechTalks.tv. This is your host Kashif Manzoor with the new episode of OTechTalks.tv. Today our session number is 87, and we are gonna continue our series or audio series on the topic which we have started a month back, which is to learn the essentials of Oracle Cloud Infrastructure. And today our session number is 5, overall session number is 5 from the OCI, Understanding Basics of the OCI. Welcome to every one of you to the podcast. And if you're new to the show, Open Tech Talks is your weekly sandbox for technology insights, experimentation, and inspiration, with the primary objective of learning and sharing. There was a short break due to Ramadan, and I wasn't able to record the number of sessions, so I just started again because next week will be the Eid holidays. So I thought let's start again where we left it. And today we are gonna cover or continue our session number 87 and on the topic of Oracle Cloud Infrastructure. And today is also Mother's Day. So happy Mother's Day, and what should I say? Without mothers, there's no word, frankly. That's what I can say. And each and every one of us, is the contribution, is whatever our mothers have done for us. This is all due to them. And even father, what they have played a role in our lives, both as a parents. So if you are listening the first time, my suggestion is to start from the part 1, and for that you need to go to otex.tv, and under the menu podcast you will get all the 5 sessions, which is Oracle Cloud Infrastructure Basics of Networking Part 1, Part 2, Part 3 Networking. Now, as a summary, till now what we have covered, overview of OCI networking, common terms, what is OCI, VCN and subnets, what are the different networking, OCI networking gateways, for example, NAT gateway, service gateway, internet, dynamic routing gateway, DRG, local peering, all those one, and default components of VCNs like route tables, security lists, and how to set up DHCP options. And then we went into the session number 4, which was that there are different scenarios, how to configure public subnet, private subnet with the VPN, or public and private subnets with the VPN. So all these areas are covered till now, and today we are gonna discuss our session is how to secure your network. What are the options available to secure your network? So different ways to secure your network. And we will start from public versus private subnets. So what you can have, you can create we already covered it, public or a private subnets, which means if you are going to put it in the private subnets, so instances in the subnet cannot have a public IP addresses, and they cannot access anything out of public IPs. So that's one way of securing your network. Then the security rules to control packet level traffic in and out of an instance. You can configure security rules in the cloud infrastructure through API or through console. And we have covered this one even in the security rules. And to implement security rules, we will go in a more detail. If you want to use through the set network security groups or security lists, how we want to achieve it, we will cover in a more detail. Then firewall rules. And we can also use the firewall rules to control packet level traffic in and out of an instance. You can configure firewall rules directly on the instance itself. For example, you need to have an image on Oracle Linux, if you're using from Oracle images, then it also contains default rules that allow ingress on TCP port 22 for SS traffic, and for images like Windows images, you can have our default rules to allow it as TCP port 3389 for remote desktop access. So these through the firewall rules. Now, firewall rules and security rules, both operate at the instance level. This is very, very important top point is. And however, you can configure security lists at the subnet level, which means all the resources in a given subnet have a same set of security rules. And the security rules in a network security group apply only to the resources in the group. So when troubleshooting access to an instance, ensure that all the items are set correctly. The network security groups that are the instances in the security list associated with the instance of subnet, and the instance of firewall rules. So all these things are properly set up. So that's very important point on that one. Then another way to secure your network is gateways and route tables to control traffic flow from your cloud network to outside traffic, or on-premise, or even into another VCN, or to the public. You need to configure your different network gateways and route tables that will ensure that you control the traffic coming in and out of the network, OCI. Then we have IAM policies, basically, which is identity and access management policies. You can control who has access to the Oracle Cloud infrastructure through, again, either a console, or you can use APIs. And you can control the type of access, which cloud resources can be accessed. For example, you can control who can set up your network and subnets, or who can update your route tables or network security groups or security lists. All these policies are available as part of the IAM policies. Then there's another way to secure the network or secure the network is security zones. You can have to use the network and other cloud resources comply with Oracle security principles and best practices. You can create them in a security zones. And I think we will go into more detail in a separate topic on security zones, because this is very important and an important topic. A security zone is associated with a compartment, and it checks all network management operations against security zone policies. And you can have, for example, security zone does not permit the use of public IP addresses and can contain only private subnets. So we'll have a separate session on security zones, because this is very important and one of the features from Oracle Cloud Infrastructure. So that's till now we covered, the ways of securing network, public-private subnets versus private subnets, security rules, firewall rules, gateways, IAM policies, and security zones. Now let's go in a more detail on this. In detail on the number of areas which we just discussed on a high level. And first we'll talk on access control, then security rules, network security, and VCN flow logs. And let's go through out of these 5 points. First point, which is access control. And I think if you are not clear about compartments and IAM policies, we have already covered in session 1, I think. So you can go part 1, and then you can have a review on that one, that what is the meaning and how the compartments are working on it. And now, in this topic of how to secure your network and under the access control, compartments and the cloud network, it's very important area. Whenever you create any cloud resource in the virtual cloud network or in a compute instance, so what we are doing is basically we are specifying an IAM compartment. So basically we are specifying a compartment where the resource need to be. And a compartment is a collection of related resources, similar resources, or that can only be accessed by certain groups or certain group of people or certain group of roles that have been given permission based on your organization access control or based on your policies. Now, these compartments can be organized based on cost center, based on departments, or based on your workload. So there are different criteria, different mechanisms you can follow. Now, the compartment administrator what he does is he creates a compartment and then relevant IAM policies or the identity and access management policies, so that who will have access to the compartments. Now the eventually target is to that ensuring that each person can have only access to the resource or the components which he need to be here. Not that he will get everywhere and whatever he can do it into different entire or on over VCN or on overall OCI. Now, if your organization is going to start on Oracle Cloud Infrastructure, and then definitely you want to give a very few people how we can create and manage the VCN and components, or even the block storage or the other gateways. All these depends on that policies which you will have. In any enterprise environment where the production environment is, definitely your organization will use multiple compartments to more easily access, control different type of resources. As an example, maybe your administrator can create compartment A for your VCN and other networking components, and the administrator could then create compartment B for all the compute instances and block storage volumes that the HR organization uses, and in the compartment C for all the instances and block storage volumes that marketing organization uses. So in this way, you can categorize, you can plan the IAM policies and all that one. For example, now HR instance administrator, which is having on the compartment B, so what he can do, that he can he is entitled to modify existing cloud network or resources which are permission to compartment B. But he cannot have access to compartment A. So similarly, you will all the service gateways, security lists, NAT gateways, VPN, and everything, all the components you will control through the access control. Now, IAM policies, that's another important that for networking. What's happening on that one? That you need to create the network policy list. So it covers basically the admin who admin rights on the cloud network, and it covers the cloud network and all the other networking components like subnets, security lists, route tables, gateways, and all the remaining one. So we can so you can assign different policies for networking on that one. Now, there are some individual resource types. For example, you want to write policies that focus on individual resources. For example, security lists only, instead of broader like a virtual network family or the instance family. Similarly, you can have, for example, resources type called local peering gateways. This is included with within virtual network family, and includes two another resource types like local VCN peering. All these type of resources, individual resources type, you need to assign and give the required access to the people or to which they want it. Now, the important component in the entire this access control for the network components or the IAM and the network and the compartment policies. Each VCN, the virtual cloud network, has various components that directly affect the behavior of the network. When we say network, mean route tables, security lists, DHCP options, internet gateways, and so on. So when you create one of these components, basically what you do, you establish a relationship between that component and the VCN. So in your VCN, if you create internet gateway or you create a route tables, you are building a relationship, establishing a relationship between the component itself and the VCN, which means you must be allowed in a policy to both create the component and manage the VCN itself, so that it can be managed on that one. However, the ability to update that component or to change the route roles, security lists, rules, and so on does not require permission to manage the VCN itself, right? Because you're creating a component, so you don't need to have an access on VCN itself. Even though changing the component can directly affect the behavior of the network, this discrepancy is designed to give you flexibility in granting least privileges to users. and not require you to grant excessive access to the VCN just so that user can manage the other components of the network. So you got the point. I mean, if you want to use and manage, although there's a relationship, there's a dependency, but if you want to manage, for example, the internet gateway and update it, you don't need to have an access to the entire VCN. You will have to that one, so that you can, user can manage the components of the network. Now, you need to be aware that by giving someone the ability to update a particular type of component, you are implicitly trusting them with controlling the network's behavior. Because these are the components which are directly dependent or are changing the behavior of the network, the virtual cloud network. So that was the short takeaway from the access control compartment in your network. Now let's go to the security rules. That's our second topic or second point for today. And I think we have already covered the security rules in default components, other default components in our session number 4. But we'll go in more detail again here so that it will be corresponding to this number. Now the network security network services, which offers 2 virtual firewall features, that both uses security rules to control traffic at the packet level. Now these 2 features are security lists, the original virtual firewall feature from the networking service, and the network security groups, a subsequent feature designed for application components that have different security postures. Network security groups are supported only for specific services. Now, these 2 features offer different ways to apply security rules to a set of virtual network interface cards in the virtual cloud network. Now, we have already covered, the security lists and network security groups, and I think you need to head to session number part 3, and then you will get into more detail on the security rules, security lists, and network security groups. What we will do, we just compare for the sake of this session, that we will compare the basics of. We know that security list acts as a virtual firewall for your compute instances and other kind of resources. Right, and a security list consists of set of ingress and egress security rules that apply to all the VNets in any of subnet in the security list associated with that. But what we will do a comparison of security lists and network security groups, NSGs. Security lists let you define a set of security rules that applies to all the VNets in the entire subnet. This is important, entire subnet. To use a given security list with a particular subnet, you associate the security list with the subnet either during subnet creation or later stage. A subnet can be associated with a maximum of 5 security lists. Any VNets that are created in that subnet are subject to the security list associated with the subnet. Now, the network security groups let you define a set of security rules that applies to a group of VNets of your choice. In the security list, we were assigning to all the subnets, entire subnet, and all the VNets and out of that one. Whereas network security groups let you define a set of security rules that applies to a group of VNets of your choice, or the VNets parent resource such as load balancers or DB systems. For example, the VNets that belong to a set of compute instances that all have the same security postures. To use a given network security group, you add the VNets of the interest to the group. Any VNets added to that group are subject to that group's security rules because you are added to that security groups. So any VNet can be added to a maximum of 5 network security groups. So the security rules apply to VNets created in the subnet that the security list is associated with it. Whereas the network security group rules apply to the VNets that are added to that network security group. Network security group, VNets are security rules, right? Oracle recommends as a best practice to use network security groups instead of security lists because NSGs let you separate the VCN subnet architecture from your application security components. However, you can even use both security lists and network security groups together. So that's up of your choice on that one. Now, definitely, we'll go in more detail. And we use the term VNIC. A VNIC is a networking service component that enables networked resource such as compute instance to connect to a virtual cloud network. The VNIC determines how the instance connects with endpoints inside and outside the VCN. Each VNIC resides in a subnet in a VCN. And when you create a compute instance, a VNIC is automatically created for the instance in the instance's subnet. The instance is considered to be the parent resource for the VNIC. You can add more secondary VNICs to a compute instance. For this reason, an instance VNICs are displayed prominently as part of a compute instance related resource in the console. There are other types of parent resources that you can create and also result in VNIC automatically being created. For example, when you create a load balancer, the load balancing service automatically creates a VNIC for balancing traffic across the backend set. Now let's go, network security groups as a source or destination of a rule. There is an important difference in how you can write security rules for network security group compared to the security list. When writing rules for NSG, you can specify an NSG as the source of a traffic for ingress rules or the traffic's destination for egress rules. Contrast this with security list rules when you specify CIDR as the source or destination. You got a CIDR blocks you mentioned. The ability to specify an NSG means that you can easily write rules to control traffic between two different NSGs. The NSGs must be in the same VCN. Now, let's, think about it. What are the best practices for the security rules? First best practice what we're talking about is the use of the network security groups. Oracle recommends using NSGs for components that all have the same security posture. For example, in a multi-tier architecture, you could have a separate NSG. So, for example, in a multi-tier architecture, you would have a separate NSG for each tier. A given tier's VNICs would all belong to that tier's network security group. Within a given tier, you might have a particular subnet of the tier's VNICs that have additional special security requirements. Therefore, you would create another network security group for those additional rules and place that subnet of VNICs into both the tier's network security group and the additional network security group. Oracle also recommends using network security group because Oracle will prioritize network security groups over security lists when implementing future enhancements. Get familiar with the default security lists rules. And this is very important from a best practice point of view. Because your VCN comes with the default security list, and this we have covered in part 1 or 2, I think, that contains several default security list rules to help you get started using the network security service. And these rules exist because they enable basic connectivity. Even if you choose not to use the security list or the default security list, get familiar with the rules so you better understand the type of traffic that your network cloud resources require. Then another third point, best practice from is don't delete default security rules indiscriminately. So your virtual cloud network might have subnets that use the default security list by default. Do not delete any of the list's default security rules unless you have first confirmed that resources in your VCN do not require them. Otherwise maybe you disrupt your VCN connectivity. And the third best practice is that confirm that your OS firewall rules align with your security rules. This is very important. Your instance running platform images also have operating system firewall rules that control access to the instance. So when troubleshooting access to an instance, make sure that all of the items that are set correctly. For example, the rules in the network security groups that the instance is in, the rules in the security list associated with the instance subnet, the instance's OS firewall rules. So this is very important that you also take care of while designing it. Fourth best practice is use VNIC matrices to troubleshoot packets dropped because of security rules. The network service basically what they offer is offers a matrix for VNICs, which shows the levels of VNIC traffic, packet, and bytes. Two of the metrics are for ingress and egress packets that violate security rules and are therefore dropped. So you can use these matrices to help you troubleshoot issues related to security rules and whether your VNICs are receiving desired traffic. So that's how you can use these best practices to improve and better manage your network security. So what I think is, I think this session is getting longer than expected. So what I'm thinking is, we have covered, out of 5 access areas which we were supposed to cover was, security rules, network security groups, network security lists, and VCN flow logs under the access control. So, or how you ensure the network traffic access. So in the security rules, I think we need to get in a more detail on the security rules. So let's, what we will do, let's cover the security rule, and then for network security group, security lists, and VCN flow logs, we will cover in our next session. Now, if we will go in a one step, down, like a ladder, or one step high on the parts of the security rules. A security rule allows a particular type of traffic in or out of a VNIC. For example, a commonly used security rules allows ingress TCP port 22 traffic for establishing SSH connections to the instance. Without security rules, no traffic is allowed in and out of VNICs in the VCN. Now, definitely, security rules are not enforced for traffic involving, the CIDR block, which includes services such as iSCSI and instance metadata. But however, each security rules specify the different areas or items. The most important components of the security lists or security rules are direction. Is it ingress or egress? Ingress is inbound traffic to the VNIC, and egress is outbound traffic from the VNIC. That's how we need to decide it while designing the security rules. Stateful or stateless. If stateful, connection tracking is used for traffic matching the rule. If stateless, no connection tracking is used. And we need to, I think, go into more detail for stateful versus stateless rules. But let's keep it on a high level. Then source type and source ingress rules only. The source you provide for an ingress rule depends on the source type you choose. Allowed source types are CIDR block, network security group, service. So for example, only for packets coming from an Oracle service through a service gateway. Then these were the source type. Then the destination type and destination egress rules only. The destination you provide for an egress rule depend on the destination type you choose, or either a CIDR block, network security group, service. Then we need to have an IP protocol, either a single IP for protocol or all to cover protocol source type, source port, sorry. Then the destination port, ICMP type. For ICMP, you can specify all types. Description, what is the security and NSG security rules include, option attribute. So all these are the options when you will define the security rule, right? And it's very important that, to understand the basic, what is the stateful versus stateless rules. When you create a security rule, you choose whether it's a stateful or stateless. The difference in a security rule, you choose whether it's a stateful or stateless. The difference is described, when we say stateful rules, making a security rule is stateful indicates that you want to use connection tracking for any traffic that matches that rule. This means that when an instance receives traffic matching the stateful ingress rule, the response is tracked and automatically allowed back to the originating host, regardless of any egress rules applicable to the instance. And when an instance sends traffic that matches a stateful egress rule, the incoming response is automatically allowed, regardless of any ingress, for example, stateful. If you show, for example, there is a picture on the available in the standard documentation, and I will put it on the OurTechTalks.tv in this session 87. This is what we covered about the so no egress rule required. Response automatically tracked and allowed. That's a stateful rules. Now in the stateless rules, Marking a security rule as a stateless indicates that you do not want to use connection tracking for any traffic that matches that rule. This means that response traffic is not automatically allowed. To allow the response traffic for a stateless ingress rule, you must create a corresponding stateless egress rule. For example, you have instance A, instance B, and then there's another picture in that one, and I will put it in the on the podcast, so that it will cover you the detail how you will use the stateless and stateful rules. Now, definitely this connection tracking details for state rules, you need to have a protocol, source and destination IP addresses, source and destination ports. All these are part of managing it on that one. So that's what we covered as part of the basics of security rules as part of the how we can secure our network. So out of 5 main areas or components of the securing our network traffic from access control point of view, we covered the access control to the compartments, and then we now cover the security rules. So 3 topics are open, which is network security groups, security lists, and VCN flow logs. I think let's keep it for the next session on that one. Thank you so much for joining the session. And just to reiterate, all the information, all the resources are taken from the standard documentation of Oracle Cloud Infrastructure, and then it's blended with some of the presenters' knowledge experience. Now, for any production migration and production settings, I would suggest you to go and consult the standard Oracle documentation, because it's just a disclaimer that it's based on personal interest and experience. This knowledge is being shared to improve and learn with each other. And thank you so much for joining the session, and I think we will continue.
Thanks for listening to the OTech Talks podcast, and be part of Tech Talks at otechtalks.tv. It's a turf to share ideas, insights, and innovations.